Hi, and welcome to Allen High School's discussion of chemical reactions at the pre-AP or 10th grade honors level. And Happy New Year, and I'm so glad that you have joined us, whether from Allen High School or beyond. Now, as we talk about chemical reactions, some of the things we're going to have to be able to do is write chemical formulas. We did that last semester here at Allen. We're going to have to then represent that which we see at the macroscopic level. We mix two things together and see a solid or a color change, and we have to represent it with a chemical reaction using those formulas. Now, it's not just enough to write the chemical reaction. We have to balance the chemical reaction. And in balancing a chemical reaction, we're going to be counting atoms. The reason we do that is we don't want to imply that we're violating the law of conservation of mass. We have to hold that intact. Conservation, I think I spelled that right, of mass. Now, that means if I start with 10 grams, I have to end with 10 grams. Now, I may have different substances. They may be bonded differently. They may be in different states, but I need to start and end with the same amount of mass. And my balanced equation has to indicate that as well. And then eventually, as you start noticing patterns, we're actually going to start predicting. Being able to predict possibilities in life is a big part of being an entrepreneur, and for new developments and new experiments and new inventions. And so we want to start looking for those patterns in our chemical reactions. So that's where we're headed. We're going to start, I'm going to assume that you know how to write formulas. We're going to start with counting atoms. Now, when we count atoms, there's two key numbers that you have to watch. One is the subscript. Now, the subscript is our bonding number. When you're balancing an equation, don't change the bonding numbers. These have to stay intact because they depend on different exchanges of electrons that we saw in the last unit. So these are going to stay intact as we write balanced equations. All right. The other one is the coefficient. The coefficient is our counting number. There may be two F's in there, I'm not sure, but somebody do a little spell check on me and correct me in class, but that doesn't look right, so I'm going to put two F's in there. That's our counting number, and that's what can change. All right, that's what will alter as we're doing our balanced equations. So let me give you an example. I have iron plus 3. Whoops, my Mimio's doing a little jumpy thing on me. And then I have sulfite, which is minus 2. So that means I have Fe2. SO3, 3. Now, that one formula unit means that there is a number 1 in front of this. I have one of these formula units or lowest whole number ratios. And the question is, how many oxygen atoms? Well, if I have 3 SO3 polyatomics, and yes, you still need to know your polyatomic ions, or maybe you ought to learn them if you never did in the first place. So I have 3 of these, so I have 3 times 3 or 3 times 3. Either way you want to look at it, I have 9 oxygen atoms. Now, if instead of that number 1, it's possible as I'm balancing an equation that I change that number, and let's say we change that number to a 5. As part of our balancing. Now, you're not going to change the 2 when you balance, and you're not going to change that 3. We would change the number in front. So if it's 5, well, if each formula unit gives me 9, and I have 5 of them, that means I have 45 oxygen atoms. Okay? Now, how many total atoms are there in 6 formula units? Barium's plus 2, chloride's minus 1. And you remember, if it's a hydrate, you add those 2 waters. So if I wanted to count those atoms, I'd have 6 barium, I'd have 12 chlorine. 6 times 2 is 12. Each water has one oxygen, but I have two waters. So I have two oxygens, and I have 4 hydrogens. So if I add that up, I've got 10, 11, 12, I think I'm counting 24. Oh, no, I made a mistake. I forgot to multiply my waters. Wow, see how easy it is to make mistakes? I'm going to keep that there as a warning for you guys. You have to be careful. This 6 applies to the water as well. So I don't have just 2. I have 2 oxygens for each, but that's times 6. And I have 4 hydrogens each, but that's times 6. So I almost made a mistake. A lot of you will make as well. So we want to keep your eye on that number in front on the barium chloride was multiplying out that whole hydrated barium chloride. Okay, I think you probably have the hang of that by now. And so I'm not going to belabor this point. We will be working on it in class quite a bit. So until we do, this is, of course, your beloved chemistry teacher signing off.